Okay, let's look at problem 677 in the 12th edition. We have this frame and the loading shown, and we're supposed to determine the forces acting on members ABC at B and C. So it's one thing that's you have to be careful of in these questions is it asking for the reactions at say C, or is it asking for the forces on the member, because those are equal and opposite. And so in this case, it's asking for the forces on the member ABC. Okay, so how do we do this? Well, right off the bat, we have how many unknowns? We have two, three, four, right? We have four unknowns here, so we can't really just figure out the external forces. And so what do we do with these frames and machines? Well, we break them up into individual components. So let's look at member ABC. So at ABC, we have this thing that comes up like that. Hopefully it's kind of drawn to scale. Here at C, I have some unknown. I have some CX, CY. At B, I have some forces going on. I'm going to put a BY and BX. And here I have a known 200 Newton force going in that direction. Okay, so I have four unknowns. So my good sense about me is going to say, hey, I know that I can only solve for three unknowns. Let's go ahead and try to solve for, say, those unknowns. I'm going to take the moment at C. That's a particularly convenient one because we get rid of CX, CY, and BX. So we're going to be able to solve for one of them right off the bat, right? It's going to be 200 times that lever arm, which is going to be 90. And that's going to make it rotate in that direction. And this BY, the way I drew it, is going to rotate in the other direction. So therefore, it's equal to BY times the distance from here over to here, which is at 240. So therefore, BY equals, I believe, 75. So I got a positive number, which simply means that I drew it in the right direction. So good for me. And I'm just putting it in my calculator. Yeah. And okay, so 200 times 90 divided by 240 is 75. Okay. But now, if I do my sum of my forces, I don't know, let's do my sum of my moments at B. See what we get at B equals 0. So now we have 200 times 90. That's also going to make it rotate in this direction. Now, the way I drew it, CX is going to pass there, but it's going to be plus CY times 240 equals 0. So CY looks like the same value is going to be minus 75. Okay, so I figure out CX and CY, and then if I look at my sum of my forces and X equals 0, I'm going to get that 200 plus BX plus CX equals 0. True, but it's still two unknowns, and sum of my forces in Y equals 0 is going to tell me that BY plus CY equals 0. Okay, yep. So that's lovely, and it's true. It's just not terribly helpful. Okay, so what do? Well, we have to go to the other member. Now, this is where I'm going to depart for just a second. There's an easier way to do this. The first time I'm going to show you the harder way to do it, and then I'll show you the easier way to do it. Let's look at member BD. BD is like this, right? At D, I have some dx, dy, and then at B, I have forces at B, and I already drew them up here. And so I always have to remember it's equal and opposite. So therefore, I have by and bx. Okay, so there we go. But I already know by, right? By is known. So I'm going to say, let's take this sum. Do I care what's happening at D? I do not. That's not been asked for. I don't particularly care. So I can say, let's take the sum of my moments at D, set it equal to 0. Okay, so I have by times the distance is going to be 120 That's going to rotate right around in that direction. And the way I drew bx, it's also going to rotate in the same direction, so that's going to be plus bx times 90 equals 0. So therefore, bx is equal to minus by times what 120 90ths is what, 4/3? Yeah, there we go. So bx is minus 4/3 by. Lovely. So therefore, I know what by is. It is 75, right? So it's equal to minus 75 times 4/3, which is equal to minus 100. So the negative just means I drew it in the wrong direction, and the value is 100. Okay, so now the beauty of that is, now that I figured that out, I can come back over to here and plug it in. So I can take this up to here. So 200, and bx is minus 100, so this could be minus 100 plus cx is equal to 0. Therefore, cx equals minus 100. Okay, so what does that mean? That means that, let's just start writing this. So bx equals, I'm going to put, instead of minus 100, I can put 100 and let's put the right direction. I drew it in going that way, so it's really in this direction. by is 75 going in that direction. Cx is 100. Again, I got a negative number, which means I drew it wrong, so it's again in that direction. And, oops, not D. Cy is 75. Again, I got a negative, so it's 75 in that direction. And boom, those are my answers. Okay, so I said that we're going to do this a slightly harder way. There's a slightly easier way. On this problem, it doesn't make a huge difference, but this is still one of those things that you really need to understand. This is super important. What do we know about BD? When you look at, remember, A, B, C, there are 1, 2, 3 places where forces are being applied. So this is what's considered a 3-force member. Okay, if you look at, by way of contrast, here, we'll change the color. If you look at BD, there are 1, 2 places where forces are being applied. So that means it is a 2-force member, and 2-force members are unique and helpful, super helpful. What do we know about them? The forces go in the line of action between where the 2 forces are applied. So in other words, we have the straight line here. We know that any forces on this member are going to be on that line. Now, I don't know offhand if they're going to be in this direction, like that, or if they're going to be towards each other. But the beauty of this is that we get rid of one of the unknowns, because the unknowns, you have bx and by. Now we don't have an unknown bx and by. We just have an unknown magnitude BD. So let's play with this for a second. I'm running out of space on here. Let's do it right here. And so instead, let's go back to the original thing. We have a force like this. Okay, so I'm going to, at C, I'm going to have Cx, I have Cy, here I have 200. Sorry, just make sure it's clear where I'm drawing. Okay, but now the whole point of this is I'm saying, hey, I have a known or an understood value on this thing. So in reality, I'm going to have, instead of an unknown x and y, I just have one unknown, say in that direction. I'm going to call that BD. So now how many unknowns do I have? Well, I only have 3 unknowns, and I can just solve for that. So the way I would do, like, some of my moments at C equals 0, which we've already done a lot of the work, but the point is then you can jump straight to figuring out what BD is, and then sum of my forces in x equals 0 and sum of my forces in y equals 0. So the reason this is important is if you had, say, an external force applied right here, so you had, say, like another 200 Newton force there, then all of a sudden this no longer becomes a 2 force member. So you don't know the direction. So you have to go back to this style of solving it, right? You'd have to put a force here. It wouldn't be that big of a deal, but it's doable. But you don't. But if it's only a 2 force member, look for those 2 force members, because then you can come and you can just solve for it directly, and you don't ever have to even look at the second member. There you go.